So here we are watching the chain rule expand and trying to get a good handle on what it means to take the derivative of the inside and the outside. So first thing to notice when you're taking a derivative is if there are any functions on the inside or functions inside of other functions, that would necessitate the use of the chain rule. In this case we do. We have pi minus 1 over x inside cotangent. The derivative is the derivative of the outside, leave the inside alone, times the derivative of the inside. So the derivative of the outside function is cotangent. Derivative of that is negative cosecant squared. Leave the inside alone, pi minus 1 over x, and multiply by the derivative of the inside. So the inside function is pi minus 1 over x, or x to the minus 1 power. When we differentiate that, we get positive x to the negative 2. Then we can clean up the derivative just a little bit. Y prime is negative x to the negative 2 times cosecant squared of pi minus 1 over x. These trig functions usually have some kind of chain rule on the inside unless the argument is just x. However, this next case we have more on the inside than just the argument of the trig equation. Look at this. This is 5 cosine x raised to the negative 4. And that's very sneaky, the way that we allow ourselves to let these exponents of trig functions sneak in there right next to the trig function itself. What it really means is that that whole trig function, including the argument, is all raised to the negative 4. That's 1 over cosine x times 1 over cosine x times 1 over cosine x times 1 over cosine x. So it all got raised to the 4th. Now the inside function is the trig function and the outside business is the exponent. So when we take the derivative, y prime, the 5 is already there. He's a constant, part of the original problem. Derivative of the outside is 4 times leave the inside alone and go down a power. Negative 4 becomes negative 5. Inside stays the same, cosine of x, times finally the derivative of the inside. The derivative of cosine is negative sine. Then we can clean it up. So 5 times 4 is 20. We have a negative from the sign. We'll let the sign come out in front and leave cosine to the back to the negative 5. Or you can let that power slip in again, how it was in the initial setup, in the initial equation. And kind of a shorthand, saves us one set of parentheses, but it's definitely more clear if it's written like this. So I really encourage you, if you see an exponent on a trig function, to write it outside the parentheses so you can identify that there really is a chain rule at play there. We also can have chain rules as exponents of a natural exponential function. So remember, e to the x is its own grandpa's own derivative. However, there's an inside in the exponent, 5x, so it's not just x anymore. Now it's 5x, which has a derivative, a non-terminal derivative. Y prime is the derivative of the outside. The derivative of e to the x, or e to the anything, is e to that thing, where 5x is the inside. Leave the inside alone, and then multiply by the derivative of the inside. If we have 5 to the x as the inside, the derivative of 5x is 5. So this derivative, y prime, is 5e to the 5x. For the next thing, same situation. The outside function is e to the something, and the something is more interesting than regular old x. The derivative is e to that thing, e to the, leave the exponent alone, 2x over 3, times the derivative of the exponent. The derivative of 2x to the third, or 2x over 3, is 2/3. And then we've differentiated all the pieces, the inside and the outside. So the derivative, y prime, is 2/3 e to the 2x over 3. If we were in class right now, I'd take a small detour and ask you to find the derivative of some basic e to the x stuff like y equals e to the x squared, or y equals e to the 3x, or y equals e to the negative x. These should become very fast derivatives for you that you just write down the derivative of the exponent times the original exponential expression. If you want to try those out and bring them to class and ask me or Jonathan if you have them correct, or of course the internet has all kinds of solutions, that would be wise. Alright, so it only gets more interesting here when we mix the chain rule up with other rules. See the next video, though, for that.